Welcome to Calbeckistan, the place where anybody can learn math. I'm Mr. Calbeck, and today we're diving even deeper into the properties of exponents and how we deal with those when they have variables inside. Okay, if you haven't started, please watch that previous video. It's going to build the foundation of what we're going to be talking about today. Link in the description. So, as a quick review, for those of you who did watch, what we learned last time was that something to the 0 power, we used the example of 3 and 2, but anything to the 0 power we figured out was 1. Again, it's not 0, it's equal to 1, and that's because we found that pattern. And what we found when we had a negative exponent was that it was actually dividing by a number. So if I had 3 to the negative 3rd power, that's the same as 1 over 3 times 3 times 3. Okay, or 1 over 27. We're going to dive into a little bit deeper stuff than that today. And we're going to begin by looking at exponents that are on top of variables. So if 3 to the 0 power is that means that x to the 0 power, it doesn't matter what the number is, anything to the 0 power is going to be 1. And if you don't have that in your notes already, please write it down. It's a really important idea. If your teachers ever give you a variable that has a 0 exponent, you just go, ka-ching, thank you. You don't have to do any more math. You just write a 1 there in place of it. What happens if I have other exponents of variables? What happens if I've got y squared? Okay, y squared, remember, something to the 2nd power or squared is something that's been multiplied by itself. I have 2 of those numbers, they're connected with multiplication. So I don't know what the number y is. Remember, it's just a number. But whatever it is, it's going to be multiplied by itself. So y squared is going to be y times y. Now if we think about our concept of the last video, we looked at negative exponents. If I have y to the negative 2 power, what do you think that would be? Well, remember, we learned that that was a division problem, because it's the opposite of multiplying a number again and again. I'm going to be dividing a number again and again. And what we found was something to the negative 2 power is actually 1 over that number times itself. So if you ever see something to the negative 2 power, you can put it 1 over itself times itself. So 1 over y times y. There's actually a faster way to write this, though, that's really cool. Y times y, we know what that is. That's y squared. So I can actually rewrite this as 1 over y squared. And I think that's a really interesting result, because what you can do is, if you have a negative exponent, you can just turn it directly into a fraction. I don't need to think about this. I can just go ahead and be like, well, that's to the negative 2 power, so that's going to be 1 over y squared. You don't need to use that middleman. You can go directly to this, which means anything to the negative power I can write down. And your teachers are probably going to give you some crazy stuff, where they'll be like, hey, what's x to the negative 32 power? And you're like, I don't know, that's a big scary thing. No, it's not, because we know the pattern. Negative exponents are division problems, because they're the opposite of multiplying a number again and again and again. So the question is, how many times has this x been multiplied? It's been multiplied 32 times, and it's a fraction. So what we're going to do is I'm just going to change that into a fraction. It's 1 over x to the 32. Whatever that exponent is, if it's negative, it's going to be 1 over the positive version of that. I think it's really cool, and it's not even that scary. It's a very easy trick. One of the things I tell my students sometimes is, what happens to negative exponents? They just go to the bottom of a fraction. You can think about this as x to the negative 32 over 1. You can flip that fraction upside down and realize what it really is. So that's some basics. Now let's see if we can do some actual math that you might see in your class with these. All right, so let's start building this together and see what we can do with this. Your teachers are almost guaranteed going to give you this question at some point. X to the 3rd power times x to the 4th. Now, your brain is going to tell you that this is x to the 12th. That is wrong. Okay, so be really careful about your intuition because you need to build a new understanding of how exponents work. You need to build a new intuition on what's going on here because this is not a regular 3 and that's not a regular 4. What that's saying is that there are 3 x's multiplied together here and there are 4 x's multiplied together there. So you need to be really careful about how you go about thinking about this because it's not a normal 3 and it's not a normal 4. So be really careful. Let's see if we can rewrite this and it will give us a better insight on what's going on. X to the 3rd power, all that is x times x times x. And x to the 4th power, all that is x times x times x times x. And, well, how are they connected? With multiplication. So if I write all of these numbers out, because remember, variables are just numbers, now I see that what I've actually done here is I've multiplied x by itself 7 times. This whole thing together, if I think about it, isn't x to the 12th, it's x to the 7th because I've got 7 x's that are multiplied together. I'm hoping that you can see this here. One of the great ways, if you're ever stuck in an exponent problem, is to change it into what it means. If you see an abbreviation x to the 3rd, that's x times x times x, and this one is 4 of them. Write them out the long way, and you'll find that it makes these problems a lot easier. So I've got x to the 7th. Let's do another example and see if that builds a little bit better understanding. So I want you to mentally, based on what we just did, see if your intuition is improving. What do you think the answer to this is? So you can go ahead and pause and see if you can figure it out. Let's go ahead and try it right here. X to the 2nd power times x to the 6th. Now the way that we're going to solve this is just like last time. We're going to break this up into its parts. X to the 2nd power, x squared, is x times x. I'm going to bring my multiplication symbol down. And this other one is x to the 6th power, which means x times itself 1, 2, 3, 4, 5, 6 times. So let's see if we can put that together. How many x's do you actually have here? You've got 8 of them. This whole thing is actually x to the 8th power. So if I simplify these two together, it gives me x to the 8th. Now, do you think that this can give us a strategy on how to, is there a shortcut? Is there something that we can do here? Now, I want you to think about it in this terms. Think about what exponents do. They multiply something again and again. This is multiplying x 2 times, this is multiplying x 6 times. But if I look at what's actually happened here, in both examples, I've added the exponents together. That's because I've got 2 of the x's times 6 of the x's, which gives you 8. So there's a shortcut, and your teachers will probably write it down like this. That will allow you to think about stuff. They'll probably write it down as x to the n times x to the m. And that looks really weird because now I have a variable and then there's a variable in the exponent. But all that means is this is a blank for any number and this is a blank for any number. And what that equals is it's going to be whatever these two add together to be. N plus m. Let's see if you can try a tough one. Based on this idea, what is x to the 50th power times x to the 102nd power? Okay, this would be really difficult to do if you were going to multiply all of these out together, write 50 x's and then 102 x's. That's pretty tough to do, but in this problem, we can use that shortcut because remember, what this means is that there's 50 x's, 50 of them together, multiplied by 102 more. So what that actually means is I've got 152 x's. See if I can actually write down an x properly here. It's 152. So x to the 152 power. Be really careful though. This is absolutely a multiplication problem. Just because I have a shortcut that allows me to add exponents, that doesn't mean I'm actually doing addition. It's a shortcut that allows me to multiply a whole bunch of stuff together to get a result. I am multiplying here. The shortcut is that I'm adding the exponents together, but that does not make it an addition problem. So please don't get that confused. Let's take a look at another operation. X to the 5th divided by x squared. Again, don't think about this as a fraction. Think about it as a division problem, and it makes it a lot easier. X to the 5th power. Let's go ahead and rewrite that. That helped us with our last kind of problem. So x to the 5th power is x times x times x 5 times. X squared is just x times x. All right, so there's two things going on here that we need to take a look at. First is that we've got a lot of things multiplied together and a lot of things divided together. Now remember, from our earlier videos that we watched in our solving crash course series, we learned that multiplication, division are opposites. And that's going to be really key here. And we can think about numbers. And maybe you don't know what x divided by x is, but you could maybe put in a number. What if it's 5? What is 5 divided by 5? If anybody says 0 out there, I will come after you. No, it's not 0. 5 divided by 5 is 1. Every time you're dividing something, a lot of teachers teach you that this is canceling out. It actually doesn't cancel out in the way that you probably think it does. What it does is it divides into 1. A lot of times what I like to do is just to draw a big 1 in here, reminding me that something divided by itself is 1. When your teachers are crossing things out and when they're canceling things out, what they're really doing is they're making a 1. If you want to cross stuff out, feel free, but draw a little 1 on it. And remember that every time you've canceled something, it makes a 1. Now here's the issue, and here's how this connects here. X divided by x, that's a number. That's a 1. X divided by itself is 1. So there's a big 1 right here. There's another x divided by x. That's another 1 right here. So I have 1 times 1 times x times x times x. 1 times 1 is just 1, and I don't even usually write it down because it doesn't change anything. So all I'm actually left with here is 1 times x times x times x, or x to the 3rd power. Let's do another example, see if we can build that next rule, the next shortcut. Some of you might already see it, which is fantastic if you do. So let's try this again here. See if you can figure out this one. Now, if you can do this in your head, that means that your intuition with exponents is improving. Remember, these are not regular numbers. This is the number of times that x is being multiplied together. There's 6 x's being multiplied together, 4 x's being multiplied together. So let's write this out like we did last time. So x 4 times and x 6 times. So let's see if we can find some more 1s. I see I've got the same thing on the top and the bottom. Anything divided by itself is 1, so I've got a bunch of them here. Now you can cross these off. I think it's kind of fun to draw the biggest, most obnoxious 1 you've ever seen. I mean, this is just a huge, awesome, mega buff 1. Here we go. He's smiling because he's so jacked. There he goes. Look at those muscles, right? All right, it's a huge ninja 1. Actually, cut that. That's a terrible idea. All right, so we have a big 1. Everything there just divides into a giant 1. Or you can cross each one out individually. It doesn't make any difference. So I'm left here 1 times x over x. And this is a really common error that a lot of people make. This does not equal x squared. This 1 is on the top as well. Okay, that 1 is everywhere. So this is actually equal to 1 over x times x, or 1 over x squared. You can even think about it as x to the -2 power if you like that better. So let's see if we can come up with a shortcut. In both cases, I've canceled a bunch of stuff out when I'm removing exponents, if you will. So the shortcut here is x to the n over x to the m. That's equal to x to the n minus m. You subtract them, and the reason you subtract is some of them are going to cancel out. And again, I don't personally even use this rule, but your teachers are going to teach it to you, so I thought I'd write it down. I like to think about it as how many things are going to cancel out. You don't actually really need to think about it as subtraction, and we can do huge numbers if we want to. But you can imagine a line of x's 38 long, right? And then you can imagine another line of x's 30 long. Well, how many of them cancel out? Well, 30 of them are going to cancel out, right? Because there's 38 on the top, 30 on the bottom. Every single one of these is going to cancel out. So what you're left with here is x to the 8th, because you've canceled out 30 of them, and there's only 8 left, and the ones that are left are on the top. If you had this the opposite way, if this was 30 on the top and 38 on the bottom, that means all 30 would still cancel out. The only difference is the 8 that are left over would be on the bottom. So you'd have 1 over x to the 8. And again, remember, this is not a subtraction problem. This is a division problem. But because we have to think about exponents in a different way, we can use the shortcut of subtraction. But again, I think it's better to think about it as how many cancel out. All right, there's one more rule. It happens if I have a power to another power. It's kind of intense. Let's see if we can write this out. It's kind of a weird idea, but I think we can do it. Let's work from the outside in. Something to the 4th power means that it's been multiplied 4 times. But think about what's being multiplied. This whole thing has been multiplied 4 times. So what this really means is x squared times x squared times x squared times x squared. 4 of them. And then I could think about each of these as being x times 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 x. Oh man. So let's count them up. How many do you have? Got 8 of them, right? So this is going to be all equal to x to the 8th power. Now the question is, what is the rule here? This is one that I really don't like writing the rule for, because I see students mess this up so consistently and so often that I actually don't like the rule. I'm going to show you the rule, and then I'm going to tell you never to use it, because I want you to know what it is, but I want you to think about it as writing out exponents here. So the rule is this. If you think about it, how do I go from 2 and 4 to 8? I go from 2 to 4 by multiplying. So if I have x to the n to the m, that's equal to, well, you guessed it, x to the n times m. I really hate that rule though. And here's why. Students will assume that this means that I distribute an exponent. You cannot distribute an exponent. Exponents don't distribute, they never have, and they're not going to, regardless of what your math teacher says. What exponents do is that they multiply something again and again and again. So the shortcut might involve multiplication, but that is not what you've done here. I have multiplied x squared 4 times. That's what I've done. So I would really encourage you, as you see these powers to a power, this is not a multiplication problem. I want you to write it out. You're going to get the right answer way more. Okay? If you are watching this and you're a little bit farther along in math, I'll show you the super common error that people make with this. Later in math, you're going to get something like this. Some of you have already seen stuff. It's called the binomial, and it's all been squared. Now, based on that last rule, a lot of students will be like, oh, the 2 distributes, and it's x squared plus 4, or 2 squared, right? This is so horrendously wrong, it hurts my soul as a math teacher. And I promise, I can guarantee that this will be a multiple choice option on the SAT, and a lot of you will pick it, and it will be wrong there too. Don't mess this up on the SAT, because that's not what it means. What this means is this whole thing has been multiplied by itself. What this really means is x plus 2 times x plus 2, and there's a whole other process for multiplying that I'll show you in a later video. But I promise, if you think about an exponent as multiplying something by itself and you write out each parentheses, you're going to get the answer right every time. If you try to do the shortcut, you're going to get it wrong a lot. So there's that. That's my video. Hope that was helpful. Stay tuned next time where we use this video, or use these rules to start doing some more challenging problems.